Here we're going to look at reflecting a function across the x or the y-axis, depending on what they're requesting of us. So in number one, write the function rule for the function shown below reflected in the given axis. So they're asking us to take f of x equals negative 4x and rewrite it to show that there's a reflection along the x-axis. Now, if you had a graph here, and let's just make a point here. So this is our x-axis, right? And let's say we had the point 2, 3. If I was to take this point and reflect it across the x-axis, so it's going to go to the opposite side, think of it like a mirror. So that point is going to drop down here. And what happens is my coordinates are 2, 3. And what you're going to notice is anytime you reflect something across the x-axis, your y value is going to be the opposite sign. So if it was up top, positive 3, it'll become a negative 3, and if it was negative, it would become positive. So anytime we're reflecting across the x-axis, so an x-axis reflection causes y values to take the opposite sign. So what that means is this equation, we can think of this as like f of x equals negative 4x as y equals negative 4x. What's going to happen, sorry about that, is the entire function itself is going to be changed to a negative. So that we could say f of x or g of x, whatever we're changing it to, I'll leave it the same. We're going to make the entire function negative. And if you were to rewrite that, negative 4x would just be 4x. So that would be equal to 4x. And if you were to graph negative 4x and 4x, you'll see that they're reflections of each other. All right, and number two, write the function rule for the function shown below reflected in the given axis. So we're doing the same thing, but this time they're talking about the y-axis. So again, if I was just to draw a quick sketch, and let's say I have this point, let's go negative 2, 1 right here. If I was to reflect that over the y-axis, this point is going to go over here. So it will become positive 2, 1. And this time what's happening is that my x values are changing. So if we reflect across the y-axis, so in a y-axis reflection, that causes the x values to take the opposite sign. All right, so it's kind of the opposite, which is good. We're mirroring it, so it's kind of your opposite, and we're changing the opposite value. So y-axis reflections causes x values to take the opposite sign. So if I go back to my equation, this f of x equals negative 9x, what I'm going to change is just the x value is going to become negative. All right, and eventually if you do rewrite this, you would wind up with 9x, but the idea is that here you have negative 9, and then in parentheses you would put the negative 9x. Most likely if you're being asked this on some kind of online program, if I go back to number 1, you're probably going to want to write the answer with this one, that 4x. Again, it will become 4x, but if they're just looking for the reflection and how to write the negative in, you're going to be more likely to write it as that step. So just to kind of review that, an x-axis reflection, the entire function, the y, is going to become negative, and then in a y-axis reflection, the individual x in parentheses there is going to become negative. So let's take a look at number 3. Without graphing, identify the vertex axis of symmetry and transformations from the parent function. All right, we've mentioned this in the past, but we have something called vertex form. So vertex form looks like this. You have A, H, and K, and A determines stretches and compressions. So let's write this out. So A is going to determine whether it's a stretch or compression. H determines our horizontal shift. And K, sorry about all the arrows here, determines our vertical shift. What's also true, and this is called vertex form, is that our vertex is HK and our axis of symmetry is X equals H. Now you do want to be careful. The H value that looks like, whatever it looks like in vertex form, it's going to be the opposite of when you plug into the vertex or axis of symmetry, and we'll see that while we work on it. All right, so we have the equation y equals x plus 4 plus 3. So let's start with the labeling. In this case, my a value is out here. That's just going to be a 1. My h value, the vertex form is minus h. This is plus 4, so it's going to be backwards. So h is actually negative 4 in this problem. And k is exactly as it appears, it's 3. So let's start with the vertex. All right, my vertex, again, is hk. So my vertex would be negative 4, 3. My axis of symmetry is x equals h. So that would be x equals negative 4. And then we need to talk about any transformations that happened. All right, so like I mentioned over here, these are your shifts, compressions, stretches, things like that. The value of 1 isn't going to do anything. All right, so there's not going to be any kind of stretch, compression, or a reflection. We'll go back to reflections in a minute. That plus 4, let me do some highlighting here. This plus 4 is the opposite of what you would normally think. So a plus 4 actually tells you that the graph shifts left 4 units or 4 places. So that plus 4 tells us that's going to shift left. The plus 3, that's my vertical shift up or down. That's completely direct. It's exactly as it appears. So a plus 3 means the graph shifts up 3 units. All right, so that plus 3 tells me that the graph shifts up 3 units. Now they're not asking me to draw this graph, but I'm going to draw a quick sketch of this just to kind of reinforce a couple things. Now my vertex is, we said negative 4, 3. So 1, 2, 3, 4 is going to be right here. And then this is going to look something like this. All right, we have an absolute value function. Now, what I want to point out is that my graph shifted left 4 and up 3. That's from the parent function, the vertex. So we went left 4 places and up 3. When you do these problems, make sure that your shifts match up with where your vertex is. Okay, if they don't match up, then something went wrong.